Hello, class. Dr. Searcy here with the lecture on the Chapter 11 lecture notes. Let's begin by noting that the title of the chapter is the t-test for two related samples. The thing that we want to remember about this is that we're still talking about this type of statistic, the t-test, that we first started learning about back in chapter 9, right? Back then it was the introduction to the t-statistic, right? We were basically saying that we're running through our four-step hypothesis process where we're using this as our final statistic that we're going to use. Let's remember also that we continued talking about this type of statistic when we got into chapter 10. That we said that now in chapter 10, we're going to be talking about using the t-test for these two independent samples, right? We spent some time talking about what the two independent samples were. Okay, so now let's just note that as we continue to talk about the t-test, we're now talking about it where we're going to use it with two related samples. So to begin with, let's just remember, what did we mean when we were talking about the independent measures designs, right? The type of t-test that we used in chapter 10. First thing, let's remember that we define this as we're using separate samples, right? The way that I talked about this was in the chapter 10 questions. That was the first question in that set of questions, right? We're saying that we're using separate samples for either comparing them when each sample has gotten a different treatment, right? In this example here, we were saying that this sample got the treatment, this sample did not get the treatment. Another way that we were saying that we could run the t-test was with the independent samples was where we take two different samples and we give them both the same independent variable. We just look to see how they're affected by the type of person they are, right? So for instance, here, sample 1 was a group of men, sample 2 was a group of women. Okay, so another thing that we want to remember about the independent measures design is we also said that we can refer to it as this between subjects research study, or research design. All right, so as I leave reviewing this information, let's just remember that we can also refer to it as the between subjects design, right? That's what this independent measures design was. Okay, so how are things going to change now with this new type of t-test? We could say that now it's all about this new type of t-test that we're saying is the within subjects design. Okay, so whereas the independent measures could be referred to as the between subjects design, now we're saying that when we're talking about two related samples, we're going to refer to that type of design as a within subject design. All right, the difference between the two is that here we were saying with the between subjects, the between is we're comparing how the subjects in sample 1 did compared to the subjects in sample 2, right? So the comparison was between sample 1 and sample 2. Here, now instead, we're not doing this comparison of one group to another group or one sample to another sample. Here, it's instead going to be more in terms of within that one sample, how the participants differ from each other. Okay, so to further explain this, let's just note that if we are going to be talking about these two related samples that we can also refer to as within subject design, let's just know that this type of design has two types to it. What are the two types? The two types are referred to as either a repeated measures design or a matched subjects design. So I'm going to describe each of these two types, and I'll begin by describing the repeated measures design first. Basically, To describe it, we could say that this is where a researcher is going to collect one group of participants or one sample of participants. And the idea is that all the participants in that one sample are going to get exposed to all the different conditions in the experiment, right? So instead of, say, them being in a situation where it is one sample got the independent variable and the other sample got the no independent variable, here it's going to be that the sample, everyone in the sample is going to get exposed to both of those conditions, right? They're going to get tested both when they haven't been exposed to the IV, and then also going to get tested when they have been exposed to the IV. Okay, so what's an example of that look like? So we got an example here, right? So we go and we collect one sample of participants, right? That one sample might have like 30 participants in it. We're going to take everybody in that sample and we're going to give them some kind of pre-test measurement, right? We're going to measure their behavior before we do anything to them. Then we're going to do the thing that we're going to do to them, right? We're going to expose them to our independent variable. After that exposure's occurred, then we're going to give them another test. We're going to give them the post-test, and we're going to see how does this group now look after they've been exposed to the independent variable. Okay, so that's how a repeated measures design within subject design looks. Now, let's take a look at how the other type of within subject design works, how the matched subject design works. First, to describe it, here we'll say that in the matched subject design, you are going to form two different groups, right? So here you're going to form two different samples. What's unique here is how you're going to go about forming your two samples. It's going to begin by you going to some population and pulling out pairs of participants from that population. Right, so you're going to go to the population and pull out, instead of one participant at a time, you're going to pull out two participants at a time. And you're going to pull out those two participants because they're going to be similar to each other in some way. Okay, so what's an example of this look like? It would look like something like this, right? Where you've gone to your one population and you've pulled out one pair of participants, right? Remember, they were pulled out together because they were similar in some way. From there, you're going to take one of the participants in the pair and place that participant in this condition. Then you're going to take the other participant in the pair and you're going to place them in the other condition. Or you can keep on doing this until you've put 30 people here and 30 people there. Right, and that's how the matched subject design works. Okay, so now what's really important to get here is when you go and you run this type of study, what is the data going to look like? How are you going to organize the data? So that's the thing I want to go over with you guys next. And let's say that we are going to organize it the same way that we've been talking about organizing data all semester long. You're going to create some kind of frequency distribution table, right? And so regardless of whether this table will work with both the repeated measures type of within subject design, this type of table will also work with the matched subjects within subject design. Basically, the way it works is you're going to have a column where you are identifying your participants, right? So here we're saying participant A, B, C, and so on. And then from there, you can say, okay, so here's one condition in the experiment. And then here is another condition in the experiment. Right, regardless of whether it was a repeated measure design or a matched subject design, you had two conditions in your experiment. or at least 2 conditions in your experiment. If this were a repeated measure design, the way it would work is you would have one group of participants, right? And say in that group, we've got participant A. Participant A would be exposed to this condition, and participant A also would be exposed to this condition. So these would be the 2 scores that participant A got in the 2 different conditions. If this were matched subject design, instead of thinking of this as a list of participants, this would be instead a list of pairs that you picked, right? And so instead of participant A, you'd have pair A, and you'd have, say, one participant from that pair here and the other participant here. So just going to talk about what's going on in this example, right? It's kind of a situation that we talked about before in a previous example. I think I knocked my camera off here, so let me fix that real quick. Okay, so the previous example that we talked about with this was where participants were exposed to some pain in some way, right? They got hurt. And after they got hurt, they got to utter something afterwards. In this condition, the thing that the participants got to utter was some kind of neutral word, some kind of like meaningless word. In this condition, after the participants got hurt, they got to swear, right? They got to cuss. And then the idea is that of the 2 conditions, the participants that got to cuss were going to experience less pain than the participants that got to just say a neutral word. Okay, so that's what they were looking at here. And the way that they're doing the analysis is they're going to calculate this value here, right? That's being noted with a capital D. What is that value? That value is what's referred to as a difference score. What do we mean by difference score? We mean that value is the difference between the score in this condition and the score in this condition, right? So here we have a 9, here we have a 7. The difference between them is a -2, right? Saying that what happened from this condition to this condition was that the score went down by 2, right? So you're seeing that for every participant from there on out, right? So for, say, B, this condition had 8, this condition had a 7. The difference score between them is -1. The score went down by 1. So in this type of analysis, right, the t-test for 2 related samples, this is your score of interest. You want to know what's the difference score between the 2 different conditions, and that's what we're going to use is our analysis, right? Remember, the theory here is these participants should experience less pain than these participants. You get to see whether that was actually the case with these numbers here. Another thing that we have to point out is that when we go to do this type of analysis, right, we, in a lot of cases, will end up with these negative signs. Remember that we don't like to use negative signs in our formulas that we calculate. So we're going to do something to get rid of those negative signs. Basically, the thing that we're going to do is we're going to take each of these D values and we're going to square it. Right? We're just going to call those values now D squared, or the difference scores squared. Okay, from there though, right, then we're talking about, well, how do you go and do your analysis? Let's just think of this as this being the data for repeated measures design. You'd want to start off with those descriptive statistics, right? Remember those things like the mean, the median, the mode, your variance, your standard deviation, and your well, those kinds of things. So we've got those calculated here as well, right here, right? So remember, this is the score of interest. And so we're going to take it and we're going to sum it up, right? What is the sum of D? Here it's saying it's -18. We're also going to take that score and we're going to sum up its square as well at 68. Right? And the reason why we're doing that, remember, is because we need to figure out what the sum of squares is for this set of data, and we're going to use those 2 values to do that. Before we do that, though, we also need to get a sense of what the average difference score was, and that is being shown right here. Remember in the book that we've been using, they always represented the average as this capital M, but my way of representing the average is that X with the bar above it. Let's just note that this is the mean of the different scores, right? So this is the mean of this column here. How we getting it? We're saying that we're taking the sum, that negative 18, and we're dividing it by the n, right? How many people were in the sample? So it's negative 18 divided by 9 gives us a mean of negative 2. From there, right, the way that we calculate the sum of squares was we used our computational formula that we learned back in chapter 4. It ended up being where you're gonna take your sum of the square differences, which is that 68, and you can subtract this fraction, which is your different scores summed and then squared. That's at negative 18 squared. That's how we're gonna end up getting, so then it ends up being that divided by this 9. That gives you this 36 here, right? So we end up with this sum of squares of 32. Okay, so what are you gonna do with that information? Remember, the way that you're gonna use it is you're gonna conduct your 4-step hypothesis test. Right, remember the first step in the hypothesis test was where you're going to state your hypothesis. Here, I thought I'd go ahead and just kind of explain how to state the hypothesis when you're running a one-tailed test, and also how to state the hypothesis when you're running a two-tailed test. I'm going to start by talking about how to state the hypothesis when you've got a two-tail test that you're doing. Remember, we've referred to this type of test as a non-directional test. The reason why it's a non-directional test is because you're predicting that you can find this t at either critical value. Right, you're not predicting that it's going to be here or here, you're predicting it's going to be either one of those two spots. So how do we write this statement? First, there's the null hypothesis. Remember your HO, which is saying that you're not going to find a significant effect. Here, the way that we state it is we say the population mean of the different scores, mu d, is equal to 0. What does that mean? It means that for the population, you're going to have a bunch of zeros here. Why zeros? Because there's going to be no difference between this group of scores and that group of scores, right? There's no difference, there's no effect. The alternative hypothesis, remember H1, says that, but there is going to be an effect. And when there's going to be an effect, the way that we're going to see it is that population difference, right? The population difference is going to be 0, or it's going to be something other than 0. Okay, so how would we state this same hypothesis if we were running a one-tailed test? First, let's note that we refer to one-tailed test as a directional test. Why are we calling it directional? Because we're saying that we're going to find our t either here or we're going to find our t here, right? So we're predicting which side of the curve, which tail the t is going to be found in. So with that, how do we go about predicting or writing the statement? Here we'll say that first, the null hypothesis is that there, again, is no difference between the two scores, right? So population mean difference is either going to be equal to 0 or something greater than 0. The alternative hypothesis here is saying, though, that our prediction is that the difference is going to be less than 0, right? The average of these numbers is going to be some negative value that's less than 0. Okay, and actually that is what we end up finding with our sample, right? It is -2, that's less than 0. Okay, so that leads us to our step 2 in the experiment. Step 2 is where we then have to go locate the critical region. Basically, you're gonna do this exactly the same way that we've been doing it up to this point, right? So we always are given some alpha level, that we're running the test at, and we're also always told how many tails are in the experiment, either 1 or 2. From there, the next thing that we always have been needing to get is our degrees of freedom. In the chapter 10 instructions, calculating degrees of freedom got kind of complicated, right? You had to calculate degrees of freedom for one group and then degrees of freedom for the other group and then add them together. We're going to not do this anymore. Instead, we're going to go back to calculating the degrees of freedom the way that we used to calculate them. We're going to say that we've got the one group that we're working with, and we're going to subtract one participant out of that group. So in this case, our participant size was 9. We're going to take one person out of the group, so our degrees of freedom then is going to be 8. Let's just kind of note from there then, the critical value that you're going to end up with is this plus or minus 2.306. And let's just remember how I got this, right? So I go to my T table, I find my 2 tails row. Within that row, I look for the 0.05 column. Right, I'm looking for that 0.05 column because that's what we were told our alpha level is. Right, I'm going to do the 2 tails row because that's how many tails we were told. From there, I'm going to my degrees of freedom of 8. Remember, degrees of freedom is over here. That's our 8 right there, and that's where our 2.306 is. Let's just note how we would find our critical value if we were running a one-tailed test. Oh, I'm sorry, no, if we were running a one-tailed test and we had an alpha level, say, of 0.01. Here we'd say that we're going to calculate the degrees of freedom the same exact same way. Now we're just saying that we're going to go find a different critical value, right? So if my alpha level is 0.01 at a one-tailed test, right, so we're going to the one-tail row, looking for 0.01, seen right there. I'm going to go to my degrees of freedom of 8, and that's where I'm finding this value that gives us this 2.896. Okay, so that's how you go and complete step 2. From there, let's just go ahead and take a look how we will complete step 3 of the hypothesis test. Let's just kind of remember that at this point, right, for every time that we've been doing a t-test, in step 3, we've basically been running through a series of 3 separate equations. Right, we're doing the same thing here, right? We're still going to start out by figuring out what our sample variance is. Then we're going to use that value to figure out this measure of your standard error. This time the measure of the standard error is referred to as the standard deviation, the standard error of the sample mean difference, right? That's what this X bar D means. Once you've found that value, then you're going to use it to find your T value. So how do you go about calculating all these equations? Remember that for the variance, it's just a matter of finding your sum of squares and dividing it by your degrees of freedom, or your n minus 1. We were given all that information earlier, right? And we said that earlier that information was where we had a sum of squares value of 32 and a degrees of freedom value of 8, right? So that gives you a sample variance of 4. From there, take that 4, we're going to use it as the numerator in our new equation, where the denominator is just going to be n, and both of those are going to be over the square root, right? So the equation becomes square root of 4 divided by 9, and that gives us this 0.667. From there, there is then the T equation. Notice, remember that this is the formal version of the formula, right? So you're taking your mean difference score and you're subtracting the population mean difference score from that. Remember one thing that we said though, we talked about this formula back in chapter 10, right? It's kind of the same thing. You've got this population statistic in your numerator. Remember that we said about this one was that you've always expected this to be your null hypothesis, right? And so it's always going to be some value of 0. For that, it's going to be the exact same thing here, right? You're still going to have this be a value of 0. So really your equation is this equation. Really, in your numerator, you're just going to put in whatever your sample mean difference is, right? And that's going to be over whatever your estimated standard error of the sample mean difference was. In this case, it's going to be that -2 divided by this 0.667, and that gives you a -3. Remember, the question is, from there, you have to move on to step 4. You have to make your decision, right? And what is the decision? Let's say that you can make 2 different decisions, right? Depending on whether you had a 2-tailed hypothesis test or a 1-tailed hypothesis test. Let's just know, to begin with, that in both cases, you are going to reject the null hypothesis, right? In both cases, you had the same critical value. You're comparing this t-value to those critical values, and in both cases, this t-value is larger than the critical value that you had here and the critical value that you had here. The difference between the 2 tails is how you interpret the fact that you're rejecting the null hypothesis. Right, so for both, also let's remember that what this means that you reject the null hypothesis is that you have an effect here, right? Whatever you did to your participants, it was effective. So you had an effect here, you also had an effect there. The difference is how you interpret what that effect is. For the 2-tailed test, right, you were saying your t is either going to be here or it's going to be here. Because you were not predicting which side the t was going to be in, the way that you're going to articulate your conclusion is you're going to say cursing had a significant effect on pain perception, right? You're not going to say that it changed pain perception in any particular way. You're saying that it did change the pain perception. And that's what we mean by it having a significant effect. The 1-tailed test, here what you're saying is when you go to make your prediction about where you're going to find your t, we are predicting that it's going to be in one of these 2 different tails. In this case, we predicted that it was going to be in this tail, right? The cursing was, or the pain perception was going to go down if the participants got to swear. So we were figuring that the t was going to be in here. Because that's the case, right, and you found that, yeah, it was an effect and the t was there, the way you're going to conclude that is you're going to say that cursing significantly reduced the pain perception of the participants. Okay, from there, a couple of last things that we need to talk about. All right, one last thing we've been talking about in the last few chapters is measuring the effect size. Right, so let's just remember that this is something that you have to think about doing if you find statistical significance in your study, right? If you reject your null hypothesis. If you reject your null hypothesis, then researchers generally also want you to measure the effect size, right? How big was that effect? We've been noting that you can measure effect size 3 different ways, either by calculating Cohen's d, and this is the formula right here for it. Or you can measure effect size by calculating r squared. That's the formula for it. Or you could measure effect size by calculating the confidence interval. Usually, if you have to do that, you'll be given some specific percent, and then you'll have to use that formula. So I'll just explain all these to you together. We've gone over all 3 of these different formulas with the different t-tests that we've been talking about already. So just going to point out how they're different here. Here, when you go to calculate Cohen's d, your numerator is now going to be that mean difference score that you got earlier. And it is going to be over the standard deviation, the sample standard deviation of your experiment. So let's just remember that the mean difference, right? The mean difference before was -2. Here, I'm writing that -2 is just simply a 2. Why am I just writing it as a 2? The reason why is because in this Cohen's d statistic, they're just looking for the absolute value of the difference. They don't care whether it was a positive number or a negative number. They just want to know what was the number itself, right? So that's why we're going from this -2 to a 2. As far as calculating the sample standard deviation, remember the sample standard deviation is the square root of whatever your variance is, right? So we said that variance before was 4, so now we're going to count it as the square root of 4, which is 2. Right, so that gives us a fraction of 2 over 2, which leads to 1. Okay, so then there's calculating r squared. The formula is the t that you calculated, right? So this is your step 3 t value. You're going to square it, and it's going to become your numerator. You're also going to square it, it's going to become part of your denominator, but plus your degrees of freedom. Let's remember that in this experiment, our t that we ended up calculating was -3. So when you go to square it, it becomes 9. So it becomes 9 over 9 plus 8. That becomes this 0.529 or this 52.9. By the way, I would like to point out, I think I kind of screwed up this in the chapter 2 or the chapter 10 odds props. The way I think I screwed it up was I think I got all this right. I think I just called this like some kind of larger number than it actually was. Whenever you get an r squared, you're always going to get it to be some decimal value with some digits at the end. And when you get that, you're always going to move that decimal value from here over the 2 spots to here, right? So you should always have some r squared value that's about like a 50% value. I think the other one that I had right in chapter 10 was like a 60%. So just kind of be aware of that correction. Okay, but moving on to how to calculate the confidence interval. Right, so this is the formula for it here. Remember what you're doing is you're solving for this population value, right? You want to have a sense of what is the population difference score for this set of data. The way you're going to get it is you're going to use your sample difference score, and you're going to add it and subtract it to the t and to this estimate of the standard error. In this particular experiment, remember that your sample difference score was that -2. We're going to keep it as a -2. The t that I've got here is this 2.306. How did I get that 2.306? Remember the way I got it was you're given this percent level. Once you get that percent level, you're supposed to look it up on your t-distribution table here. And then once you get into the column that you're supposed to go to, right, so here we're told it's 95%. Once I'm inside that column, you find the specific t by going to the degree of freedom associated with it, right? Our degrees of freedom was 8, so it's still that 2.306. That's how I got the 2.306 here. I'm multiplying that 2.306 by my standard error, which is this 0.667. That turns into this 1.538. So what am I going to do here? I'm going to take that -2 and I'm subtract that 1.538 from it. It's going to give me this -3.538. And it's also going to, and then I'm also going to add the -2 to this. Now positive 1.538, and that's going to give me this negative 0.462. By the way, one thing I've kind of noticed, right? So that's how you solve for your confidence interval. Now the next point that I want to make is one thing I've kind of noticed in the questions is that at the end of some of the questions, they'll ask you to write out the answer as you would see it in a research report. Here's how you would see this study's result written out in terms of a research report. Right, and we've kind of done this in the past, right? I think I've shown you examples of this in a couple of questions at least. You start out by talking about what your result is, right? So here, changing from a neutral word to a swear word reduced the perceived level of pain by an average of 2 points with a standard deviation of 2. The treatment effect was statistically significant, right, comma, T. What's in that parentheses? Right, it is your degrees of freedom. So you're saying that you got a T of this -3 with those degrees of freedom using that probability, and your R-squared value was this 0.529. Okay, last thing I want to end off with on this is some people ask, well, what is the advantage of using this type of T statistic design? Why would you use repeated measures design? So I thought I'd answer it by going over both what the advantages are and the disadvantages of this type of study. First, the advantages are that, one, in this type of study, you can use fewer participants, right? Think back to, we talked about that within subject design. And the within subject design, you're just collecting one sample of participants instead of 2 sample participants. Because you're only collecting one sample of participants, you can collect fewer participants. Why does that matter? Why is that good? Why is that important? Sometimes it's the case that when you run a study, you may be using participants that are rare or hard to find. Maybe you are using participants who have a specific level of depression, right? And there aren't very many people that have that level of depression. It's easier to run a study like that using within subject design because you have a need for fewer participants. So that's one advantage. Second advantage is that you can study change. What do we mean by this? This is that idea where you can look at how people were before the intervention, and then you can look to see how they change after the intervention, right? So that's that second advantage. The third advantage is that when you use these kinds of designs, you can reduce the individual differences. What do I mean by this? I mean that, think about back to that independent samples design. You had a sample of participants here and a sample of participants here. 30 people in this group, 30 people in that group. A lot of variability in there, right? A lot of people who are different from each other. If you go back to this kind of design, right, say where you're using the one group of participants, you're reducing the individual variability when you're having the participants that are serving as their control participants also being the participants who get the treatment. So it's that advantage. But then there are also a couple of disadvantages to using this design as well, right? One disadvantage is that if you see an effect, right? Say if you see participants like improve in a skill, they're improving in the skill may not be, say like your intervention was like you taught them using some kind of fancy new teaching technique, right? And so you're thinking, oh, my new fancy teaching technique was what made the difference here. Could be the actual opposite. Could be that your fancy teaching technique didn't do anything. It could be that actually the reason why your students learned was because they had some prior exposure to what they were supposed to be learning, right, in that pretest. Maybe they learned about the information in the pretest. They gave us information, so that's why they did better in the post-test. Another disadvantage is this order effect thing. Maybe the order of the effects or the order in which you gave the treatments could impact how the participants do in the study. Okay, so that's everything I have as far as this chapter is concerned. So we'll go ahead and leave it here. Thank you very much.